So the neighbor address that you are going to use for peering should be loopback whenever whenever you got a redundant path to reach the neighbor, a redundant path. So whenever you have redundant path, it's a good idea to use loopbacks because you got redundant path. And even here, if you see you got redundant path, so whenever you got a redundant path, it's always to use loopbacks so that if any one of the path is available, that's enough for neighborship. Now, what if I have redundant paths between EBGP like this? When you have EBGP redundant EBGP connection, two cables ISP has given you. Two cables ISP has given you. But how many peerings you're going to do? Only one. Same policy what you followed for IBGP, you need to follow. Use loopback in order to form neighbor whenever you got redundant link, so that if any one physical connection goes down, you still have neighborship via other link. Is that point clear? You can use loopback interface address even for EBGP, not only for IBGP. Whenever you have redundant, you will have loopback. But you remember we learned earlier in the previous chapter that EBGP neighbors need to be directly connected. Yeah? EBGP neighbors need to be directly connected. As a result, the loopbacks are not directly connected. Because the loopbacks are not directly connected, there is something extra configuration needed when it comes to EBGP. You need to do something extra. In IBGP, all that you do is update source loopback 0, because you're using loopback interface address as the neighbor. But in EBGP, because the neighbors need to be directly connected, there is something additionally you need to do something more. Look at this. You got this command even in EBGP, you got this command same like what you had in IBGP. They are EBGP. But additionally, if you see here, you are incrementing the TTL value. What does this multi-hop 2 means? It means that you are telling BGP that my EBGP neighbor is not just one hop, he's more than one hop. See, listen carefully, this is confusing thing. Many people they don't have the clear understanding on this topic. So I repeat, listen here, you got autonomous system 10, autonomous system 20, and we got a loopback IP address 1.1.1.1, 2.2.2.2, and we got multiple connections. Earlier in the previous chapter, what it was saying, EBGP neighbor should be directly connected. Do you remember that?
Yes, sir.
What does that mean? It means that in the routing table, the address that you are going to configure as neighbor, what will be the neighbor here? 2.2.2.2, isn't it?
Right.
That should be seen as connected. Is that possible?
No.
No, because 2222 is not in this interface or in this interface. It is behind the router. It's loopback. So it cannot be seen as connected. Is this one hop? Of course it is one hop. Of course it is one hop, but the loopback is not seen as connected. So you need to say, my neighbor can be two hop. When you say that, you are breaking this rule. Which rule? EBGP need to be directly connected. When you say, my neighbor can be two hop or three hop, when you say that, when you say my neighbor can be two hop or something like that, what does that mean? It means that that default rule is not valid. This two need not to be directly connected. It can be a static route. You understand? It can be
Yes.
S, or it can be learned through OSPF. It can be learned through EIGR. It can be static. You mean to say that the neighbor that I am peering with is not connected in the routing table. It can be via some other hop. So whenever you say EBGP neighbor address, EBGP multi-hop 2, two things you are saying. One is my neighbor is in two hop away. Secondly, my neighbor is in two hop or less than two hop away, two or less. The second thing that you are saying is my neighbor need not to be seen as connected C. It need not to be C in the routing table. It can be S, it can be O, it can be dual D, it can be anything. It's not going to be C. Usually for EBGP, the neighbor need to be C connected in the routing table. Got it?
Yes, sir.
All right. Fine. Now, what is really happening when you give this command EBGP multi-hop 2? When you say EBGP multi-hop 2, the outgoing TTL of the packet. See, there are two things for a neighbor. For a neighbor, there are two things. When a packet is sent, there's going to be a TTL value. When a packet is received, that packet will also have a TTL value in the layer 3 header. Yes or no?
Yes, sir.
So for a packet, when it is received, you will check TTL. When you send the packet, you will put TTL. Now, when you say EBGP multi-hop 2, what you exactly mean is, you mean outgoing TTL is 2. Outgoing TTL is 2. Incoming is 0. What does this mean? This means that when you send the packet, you will put TTL 2 and send. When you receive the packet, even if the packet is 0 TTL value, you will receive. You got it?
Yes, sir.
If a packet is coming with TTL 100, will it receive? Yes, it will.
Yes, sir.
When a packet is sent with, when a packet is received with 20, also it will receive. When the packet is received with 2, also it will receive. So incoming 0 means the packet may come from anywhere, I don't care. But I am not going to send too far. I'm going to send only 2 hop away. I'm not going to send it to very far. I'll send only with TTL of 2, which means the packet cannot go more than 2 hop. You got it?
Yes, sir.
So by saying 2, it is not meaning that my neighbor is exactly 2 hop. My neighbor actually, how many hop away he is? 1 hop, isn't it?
Yes, sir.
But by default it is 1 only. Then why it is not forming neighbor? Because the neighbor is not seen as connected in the routing table. By default, neighbor need to be seen as connected in the routing table. That's the rule. For security, For EBGP security, it is designed, BGP is designed like that. But when we say EBGP multi-hop 2, we break the rule. We say it need not to be seen as connected. It can be anything else, like O or OSPF, SR, static, anything like that. And outgoing TTL is 2. That is also very important. You are saying that my neighbor cannot be more than 2 hop away. If my neighbor is seen in less than 2 hop away or equal to 2 hop away, you can form neighbor. We are granting permission. That is going to limit the number of hops. See, because it's EBGP, I cannot simply send my packet to a very far place. What if there is someone spoofing as a neighbor in the 10th hop? That's dangerous. So outgoing TTL as slow as possible is good. That is why by default it is only 1. What is the outgoing TTL by default for the EBGP? 1. You know what is the outgoing TTL for IBGP?
IBGP 0.
No. Outgoing TTL. Outgoing,
No, I'm not sure.
if you put 0, no, it won't go outside.
255?
Yes, that's right. For IBGP, it is 255. For EBGP, by default, it is 1. But by saying EBGP multi-hop 2, you have increased. All right, so that is what needed here. You please pay attention to this example here. If router A wants to form neighbor with router B, first of all, there should be a reachability. First of all, there should be a reachability. For that, we give a static route because we got 2 gateways, isn't it?
Yes, sir.
On either side, you give 2 static routes, followed by the usual command whenever you use loopback. And you know why you need to do this? You need to do this so that the source address can be changed. Otherwise, the egress interface, the exit interface address will be the source, and it won't match with the neighbor statement, and the neighbor will not come up. You remember the previous class? The source address of the BGP packet should match with the neighbor statement.
Yes.
So that's why we put update source loopback 0, and EBGP multi-hop 2 is what we just now learned, so that you are saying 2 things. One is, I am not going to form neighbor if my neighbor is more than 2 hop for security reason. Second thing, what you are saying is, my neighbor need not to be seen as a connected network in the routing table. All right. So this is very important. So far, what we have seen is very important.
Multiple.
See, the use case is multiple path. But if you will use even in a single line, it will work. There is no problem. As long as there is a reachability, it will work. So when you do the lab for testing, you don't need to put 2 lines of EBGP, physical lines. No need. Just a 1 line.
Yeah, but the reason why I was asking, I was trying a lab yesterday, and I put the loopback address. They are reachable in OSPF. However, when I said update source loopback, it didn't want to work. It's for some reason one side is up and another side is not coming up. But when I put both loopback, it just didn't want to work for some reason.
That is not possible because we have made some mistake. That's why it's not coming up. All right. Let us troubleshoot that. Or I'll do one thing. I'll do the lab now. When you are trying to form tunnel between 7 and 3, there is no need for BGP on R1 and R2. Pretend there is no R5 and R6. Okay, we don't have R5. We don't have R6. We are not in router protector class. It is done already. So pretend you don't see R5 and R6. So there is no need for BGP in R1 and R2. You just want to form tunnel between R7 and R3, okay? So you want to form tunnel between R7 and R3. So going to R7, I want to check whether I got a loopback. Show IP interface brief. I don't have loopback. I'm going to create one interface, loopback 7. and IP address 7.7.7.7 255.255.255.255. I'm not going to advertise this network in BGP, not necessary. I'm just saying IPOSP 1 area 0 so that I'll be having reachability. Now I'll go to R3 and interface loopback 3 IP address 3.3.3.3 255 IPOSP 1 area 0. So in order to do three-way handshake, BGP uses TCP, no? So three-way handshake, I need to have reachability. So let me try pinging between R3 and R7. I'm in R7, ping 3.3.3.3 because source 7777. Because I'm going to source from 7 only. Okay, I'm able to ping. That's a good news. Now let us go and configure BGP. Before I configure BGP, I would like to use Wireshark. Okay, I've started capturing, ignore this OSPF. We want BGP packet. There is one BGP keep alive message going to router 7 from router 1, you see, router 1 to router 7. I want you to ignore that one as well. Okay, or I'll do one thing, I'll remove the neighborship. Do you know the command to remove the neighbor temporarily? Router BGP 1000. In order to temporarily shut down the neighbor, you don't need to remove it. We got shutdown command. I'm going to shut down this command. Neighbor shut down. Okay, so I should not be saying anymore keep alive. Right, I mean, neighbor is gone down. I may be receiving packet from 7, but one is not, from 1, but 7 is not going to send. From 1, I may receive a packet because in 1 I did not remove. But from 7, there won't be any BGP packet going. See, this is a reset, finish. It's actually closing the neighbor. If I want to completely stop it, I need to go to router 1. Okay, on R1, I need to remove the neighbor. Router BGP 1000, neighbor, this guy, shut down. Okay, so hereafter I should not see any TCP BGP packet because there is no neighbor. So you will not see, only OSPF packet will come. And now I'm going to ping and show you. You will see ICMP packet going. I don't know what happened. Maybe because of my CPU. This ICMP should come actually. Maybe my CPU is shopping.
It's okay. Let's just carry on.
No, what if TCP don't come like this? Huh? That's very important. I want to show you something very important. That's why we opened this Wireshark. See, it's not even, okay, now it's closed. It's because of CPU only. There is something called NP-cap, network packet capture, that needs enough CPU.
They say the CPU is 99%.
Yeah. Let me try pinging once again. I should see that ICMP packet. Only then my Wireshark is good. Okay, good. We got ICMP packets there. Okay, we are back now. Between R7 and R3, we are going to form neighborship using loopback. On R7, show IPBGP summary. As of now, there is no neighborship, and this is administratively shut down. So ignore that. I'm going to say router BGP 1000 neighbor is 3.3.3.3. Remote AS is 1000. See what happens. Even on the other on router 3, I'm going to say router BGP 1000, and you got a neighbor called 7.7.7.7. Remote AS is 1000. The neighbor won't come up because of this reason. If you see, the source address is 333, and here the source address is 10, 17, 17. Exit interface address is becoming the source. Let me filter and show you the TCP packets. If you see the TCP packets, they are sourced from the physical interface, which is not considered as neighbor on the remote router. You got it? So what we need to do is we need to change the source address. Only then the neighbor will come up. Okay, because then the TCP is not happening, three-way handshake is not happening. It get resetted because the neighbor is not.
I think that's what was happening to me yesterday. That's exactly what was happening to me.
So all that you need to do for that is you need to put the neighbor statement, update source command, neighbor 7.7.7, update source loopback. I think I do 3 here. And then on R7, you need to say neighbor. See, it has come, but you should do it on both sides. Update source loopback 7. Okay, so when you source it with a proper source address, the neighbor comes up, and when you go to the Wireshark, now you will see the source address got changed, and the source address matches with the neighbor statements neighbor list. Let's go to the Wireshark now. I'll go to the Wireshark, and I'll see here. You see, the source and destinations are exactly what we want to see. Only after that, if you see here the open message, keep alive message, route refresh, everything happened. All right. Yep. Okay. Now, one more thing that I want to show you here is the TTL. All right. I want to show you the BGP packet's TTL value. It is IBGP, no? So TTL value will be 255. All right, let us see that. Look at this. I'm receiving a packet with 253 because it was sent as 255. And now if you see the sending packet, it is 255. You got it?
Yes.
On router 7, I'm receiving it as 253 because router 3 is 2 hop away from router 7, isn't it?
Right. Yes.
Okay, now I'm going to close this and close this. And I would like to go to command line to show a few more things on the command line.
What about EBGP?
We are going, but we need to sniff in the other locations, right? That's why I'm closing this. Otherwise, my processor will chop. See, I closed the Wireshark here because we need to sniff here, right? For EBGP.
Okay.
I'm stopping the capture here. All right, and now where are we? Between R7 and R3, I want to show you a few things on the command line before I go to EBGP. You see, show IP BGP neighbor. This command is going to show you the TTL informations. It's gone up. Look for 3333 neighbor. Not this one. This neighbor is down. I have shut down. So you need to look for the other one and look at this. The outgoing TTL value is 255. For IBGP, to go to 77, local is 777. To go to the remote host, the TTL value is 255. You got it? And the outgoing port number is 179. And the incoming TTL value is 0. Now let us go to EBGP now. I'm on R3 and I would like to see whether any neighborship is already there. Show IPBGP summary. Yeah, I'm going to shut down this EBGP neighbor. Router BGP 1000. Shut down. Neighbor. Shut down. Alright, likewise I'll go to router 4 and shut down. Router BGP 2000. Neighbor 3 and 1. Shut down. Okay. Now I'm going to sniff the packet before I configure. I would like to go and add a loopback interface called 4444. Right. We are in R4. In R4, I'm going to add loopback 4 IP address 4.4.4.4. This one. Yeah. And listen. This is EBGP. If you are going to form neighbor between 3333 and 4444, what is needed? Reachability is needed. So I'm going to form, I'm going to write static route in order to form, in order to have reachability first. First thing should be first. So shall we write IP route 3.3.3.3 255.255.255.255. Send it to 200.0.0.1. You got it? Likewise, I'll go to router 3. IP route 4.4.4.4. That is newly added interface on router 4 to form neighbor. 255.255.255.255. 200.0.0.2. Now you see, this network is what I'm going to use as a neighbor. Is this connected directly? No. But for EBGP, it should be C. It should be connected. Because of that reason, you see, when I say router BGP 100, neighbor 4.4.4.4, remote AS is 2000, and I'm also giving update source. Loopback what? Loopback 3. And on router 4, I'm going to say router BGP 2000. Neighbor is 3.3.3.3. Remote AS is 1000. Neighbor 3.3.3.3. Update source loopback 4. Even after saying this, you will not see any packet. I repeat, you will not see any packet going in between 3 and 4. No TCP packet, no BGP packet. The reason is, the basic rule is what? EBGP need to be directly connected. Because that didn't satisfy, even though you have a static route, It will not even try. It won't even try to send any packet. It will be very silent. It won't send any three-way handshake packet, no sync packet, nothing. It will be very, very silent until the basic rule is broken. What is the basic rule? EBGP multi-hop 2, when you say that neighbor need not to be directly connected. Unless you break that rule, no, by saying EBGP multi-hop, the packets won't go. By this time I should see, look at this. There is no TCP packet, no BGP packet. TCP. There is no TCP. Because the basic rule is not met. So let's go to R1 to break the rule. So on R1 I'm going to say, R3. I'm sorry, what did you say?
It's not R1, it
yeah,
should be R3.
Right, thank you. I'll say neighbor 4.4.4.4 EBGP multi-hop 2. And then on R4 I should say neighbor 3.3.3.3 EBGP multi-hop 2. After saying this, you will start seeing neighbor. Look at this. Oh, wonderful. You see? First, the three-way handshake was successful, and then open message was sent. Keep alive update. Everything is done. Very neat. Now, if you go and check show IP BGP neighbor, you will see what I was talking to you earlier, the TTL. See, with 3333, the TTL is going to be 2 outgoing. Outgoing is going to be 2, but incoming is 0. Yeah. Outgoing can be 2. All right. So the neighbor is established.
Okay.
Now, I'll ask you a few questions, and if you are very clear in the answer, then I'll take you to one more step. Otherwise, I'll push it to tomorrow. Let me ask the question to you. Are you ready?
Yes.
Snip. Things. Okay, I don't want to list. Okay, so what I would like to ask is now, what will be the incoming TTL and outgoing TTL?
The incoming TTL. All right. For what? For router 3 and 4?
Yeah, answer is 6.
Okay. Right. The outgoing TTL would be 2, and the incoming TTL would be 0. But it could be anything.
Yeah, but
it could be 10. It could be 20.
When you say minimum 0, it means it can be anything. Okay. So answer is
okay. Minimum 0. Right.
0. Now, listen carefully. Here, what we are saying is, I will send the packet with a TTL of 2.
Yes.
What is that meaning? My packet will not go more than 2 hop.
Right.
What is the use? Is there any benefit for me? Let's say I am R3. I'm saying I will give my packet only to 2 guys, 2 hop away guys. What is the use? It's not.
Okay.
It's not really safe. See, no, I'm not talking about that use. It's not a question. It's not a question to test that concept.
Okay.
I know the use. When you say two, it means that it need not to be directly connected. I appreciate that's what you are trying to say. But is there any contribution to security here? See, by saying TTL EBGP multi-hop 2, what you did is you broke that security. What was the security? Neighbors need to be directly connected. It's a security one. It's a security one, isn't it? It's safe. It's secure. But you have broken that security now. By saying EBGP multi-hop 2, you have broken that security. What if the second hop? See, if it is one hop, it is directly connected. It is safe for you. If it is more than one hop, is it safe? We don't know who is hiding anywhere. Who is spoofing? You know, if I see Robert with my eyes, then it is confirming that I'm talking to Robert. What if I say I'll talk over the phone and someone is spoofing Robert in his voice? I will not know because I cannot see. He's not one hop away. He's more than one hop away. He's behind somewhere, behind the phone, somewhere. So seeing and confirming is not possible, right? So we have broken that security which was freely provided by EBGP by saying EBGP multi-hop 2. Now, there is a concept, a security concept to solve this problem. What does that do? Instead of focusing on outgoing, it will say, hey, I will send to 255. I don't care who is receiving it, but I'll focus on incoming. I'll make sure my neighbor is not more than 2 hop away. That is more secured, right?
That's correct.
I'll make sure my incoming, when I receive the packet, it should not be 251 or anything less. It should be 252 or 253. Sorry, 253. It should not be 252. It should not be 251. It should not be anything less than this. It can be 253 or 254. You understand? You got it? If your incoming TTL is 253, then you have really a safety checking mechanism, isn't it? There is no use of focusing on outgoing.
That's correct.
This is focusing on outgoing. Which one? The one which we learned in this presentation is focusing only on the outgoing. EBGP multi-hop is not focusing on incoming. But you need to focus on incoming. That is what's safe. So I'm going to teach you something which is not in this presentation. So it's not big deal, it's very easy. Just a change of command. I'm going to go to router 4 now. And before that, let me stop. Maybe this is consuming CPU. Right. So only a change of command. What I'm going to do is I'm going to go to router BGP 2000 and say this EBGP multi-hop I'll remove, okay? And then instead I'll say neighbor 3.3.3.3. Listen, command is TTL security hop 2. Yeah? Easy, no? Makes sense, right? TTL security hop 2. And now I'll go to router 3 and remove this EBGP multi-hop and say neighbor 4.4.4.4 TTL security hop 2. Now also you will see neighbor coming up. Let me go and check it in R4. Now, if I'll go and check show IP BGP summary, I still have the neighbor. Now, if you go and check show IP BGP neighbor, now you're going to see the incoming TTL is going to be 253. Incoming TTL is 253. You don't care what outgoing TTL is. Yeah? Yes. All right, so we stop here.